Hello everyone, welcome to the next video in our series on Whack-A-Mole. If you're joining us here, as always, I recommend start at the beginning, video number 1. This is video number 4. Actually, it's more like video number 3.5, I think. I mean, it's the 4th video I do, but conceptually I'm fixing something that came up in video number 3. You will inevitably remember, because I'm sure if you're watching this, you have seen video number 3 and you have watched it in its entirety. I hope, although of course I do get statistics from YouTube that seems to indicate otherwise. Nevertheless, at the end I was kind of a little bit rushed because someone was ringing my doorbell, right? And all I did this. Let me just like switcheroo. Did that work? It did work. All right. Yeah, so what I did, this is my whack, as pretty much as we left it. It was a squirrel code, right? So I had like when the green flag is clicked, we hide or master squirrel. The original, I call it the original, so that's the one that isn't a clone, and as the only one that that won't get deleted if you call the delete this clone block. So the master hides, the original hides. As it happened, it was like, it's wherever it was left by the spawning system. When I receive tick, I spawn, right? So the spawn definition is all here. You remember we've kind of done that. At the end, it creates a clone, so it goes to the specific location, creates a clone. Doesn't show it just yet, because then when I start as a clone, we show. But then the problem we had is that we were sort of multiplying squirrels, because the original will get, the first tick, the original will spawn, so it'll pick a slot, random, creates a clone of itself, so now we've got 2, but the original's still hidden. When I start as a clone, so the clone just created, just started as a clone, shows itself. Now we've got 2 squirrel. Now, when you've got clones, all of them run separate, like the code, like they all run the same code. In particular, they're all listening for the same messages. So the next time we get a tick, we have the original hidden, that will then go to another location, another slot, and then create another clone. And then the clone will also do that, weirdly. And so now we've got 4, and then 8, and then 16, and so on. So in order to remedy that, I had done something that worked well in Flappy Bird and in when I did my own kind of little, test trial version of the project, which is just like when I receive tick, delete this clone. So the idea is that when we receive the tick, we'll delete all of the clones that are clones, because the original, the master copy, cannot be deleted. It will ignore this block, and only it will then spawn. But that is based on the assumption that this, when I receive tick, delete this clone, will run before this has got the chance to run, because this creates clones. We want kind of all of the clones to be deleted so that only the original can create clones. And I thought, because that's what I did last time, and in all the places I used that technique, I thought that was enough. But let's have a look. 1, 2, oh dear. 2, it's probably more, because they could be like in the same location, right? So like, so that doesn't work. And why does this not work? Now, because if you have a look at that, let's have a look at what we have, right? They're organized in order. When the green flag is clicked, we hide. When we receive tick, we spawn. Spawn is defined here. At the end of spawn, we create a clone. When I start as a clone, I show. When I receive tick, I delete this clone. Now, that doesn't work. But this, however, which is largely the same, green flag is clicked, I hide. We define spawn the same way. When I receive tick, I spawn. When I start as a clone, switch custom to squirrel. This has got obviously more than one version because the squirrel can be hurt, but then we show. And then when I receive tick, delete this clone. And this does work, because 1, 2, just the 1. So how come this? That's called a race condition, in that like when you've got parallel execution of program that's liable to sort of change the same data, and it really depends like who gets to run the code first. It's like a race. Hence the terms race condition. In that instance, so race condition is we have 2 handlers, we have 2, top blocks, which are what is the event that starts the script, the chain of blocks. And both of those are when I receive tick. And it's really important that the deletion runs before the spawn. And in my old project, which still has the grid in the background, that's how you know it's the old one. And the mallet looks a bit different, I think, too, right? Yeah, a little bit. Well, in the old one, through some magic, I know that the deletion will run before the spawn, because by the time the spawn runs, there's only the original left. None of the clones are cloning themselves. However, in my tutorial version that I'm making, I've got the exact same code, but it doesn't work the same way. So I just kind of wondered about this forever. So the simple way to do that, if you've got race conditions, like typically with that kind of clone and cloning of clones, and you want clones, and of course clones will run the code, and you might be listening or waiting for an event, or have something on the master copy that will create clones of itself, but you don't want clones to create clones. So what you need to make sure, you will have this thing where like on the same, ultimately the same event, in that instance, the tick message will result both in creation and deletion, and you want deletion to happen before the creation. So in order to do that easily, it took some time, but you can just wait for a tiny bit. So I'm going to wait before spawning, right? Because I want delete to run first. Our tick is every second, so we're like going to put like 0.01 second, like 1 cent a second, 1/100th, 1 centième, 1% of a second, like 10 milliseconds, if you calculate 1 centisecond. And that's enough to make sure that we're going to hold here for a bit whilst all of the clones get deleted, or it should just be the one clone, right? Because now we only have like one hidden original and then one active shown clone, and it's the shown clone that kind of will basically play the game. Because remember, hidden sprite, very much like costume, and not just costume, they're also the full state, because you can drive logic, you can pick up the costume number and change it and so on. In the same way, show hide visible in Scratch is not just about visibility, it's actually active. So a sprite cannot interact when it's hidden. That means that things like touching and so on don't work, but it will still listen to messages, as we've seen, because our hidden master thing that. So all I've done here, right, remember, I just like a tiny bit of delay before the one I want to come last, which is spawn, and then no delay before that. And when I do that, it fixes the problem, because I have this little delay. But I like I was really scratching, and I understand what I understand what the problem is. I understand that this fixes it. What I don't really understand is like, how was this ever working? Because for some reason those two blocks, right, delete runs before spawn, and I don't need to put a wait to make sure that delete runs before spawn, right? Yet those two blocks, they don't, so I have to put a wait in. And then I found that basically, that's a long story, right? But it depends in the order in which you have created the event block on the canvas. It's like that arcane, if you will, or simple. Because they just they go into the memory of the program or whatever in order they're created. So like it was created first, so it runs first. So for instance, like look, this is my old version. Doesn't have the fix, doesn't need the fix because the problem doesn't manifest. The reason the problem doesn't manifest is that this clearly was created before that, because this runs before that. And if you just want to be convinced of that, I'm going to swap them around. And that now when I start, yeah, now I have the problem, right? So yes, so the solution to race condition is don't hesitate to have like a microscopic. I don't know how like small you can make the weight. I would have made like 1,000 of a second if I could. And that's probably, yeah, that's still enough, right? So you can have a microscopic weight. However, if you want the background of it, race conditions, when you have on the same sprite blocks of code that start with the same event, so the same header or the same handler, because we handle events, that's you'll see those terms will then make sense when you start proper software engineering. So yeah, to avoid race condition, when you have the same top block, right, the same event top block handle, I'm gonna call it like this little tab, right? Because it's got the so when you get two of the same, you have no guarantee in which order they will run, and sometimes it doesn't matter. You can run them in parallel, and that's fine most of the time. That's why most of the time we get a whole bunch of like when the green flag is clicked, when the green flag. It doesn't matter when they run, right? But sometimes it does matter, and so in that case, what you want to do is make sure that just delay ever so slightly the one you want to run last. But it's interesting to know that under the hood, as it were, within Scratch, the order in which event handlers, so those top level blocks, are processed is the order of creation, the order at which they were dropped on the canvas. So that was part 3.5. Let's see if I can just do it again. Did that work? No, it didn't work. God damn it. Why? Come on, come on. It's fade? Yeah. All right. Okay, remember race condition, da, 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 da. We've done the recap, and so on. So yeah, that was 3.5. It kind of doesn't count. I was just fixing a bug from 3, but like really, I mean, it puzzled me, right? It's not like, oh, I forgot something and I'm just making a thing. You're seeing this video now, but I spent significant amount of time figuring out why I had this problem in one, why I didn't have the problem in the other. But then I learned not only how to just fix it quickly with just this little wait block that you put, remember, in the one you want to run last, not in the first. And if you get more than one, you might time them with several little 1 millisecond, 2 millisecond, and so on. But if you find yourself having a lot of block running of the same handler, you may be doing something wrong because they maybe want to run one after the other. The only reason I can't make them run one after the other is because the delete this clone block, I can't have anything after it. But interestingly, the source, like the original, will ignore the delete this clone block. So for the original, it would be helpful to have like, if it's not a clone, then run that afterwards. Because then I could put my spawn call below delete this clone. And so like when I was tick, all of the clones are going to delete themselves, and the only one remaining will be the original, and the original will be able to run the spawn. But I can't do that. So yeah, improve Scratch now, MIT. What are you doing? Yeah, so that's 3.5. I'll see you very soon for the actual video 4, where we're going to start adding actual hit and hitting the squirrel and damaging the squirrel and whacking the mole or rodent or otherwise small mammal of your choice. So I will be seeing you very soon. Happy coding.